When you guys talk about karst, what are you talking about?
We knew they were black bear bones. Dave recently got them dated and got an age date on them of about 17,000 years.
You were showing us on the map, Tom, what might be a short-faced bear.
What you find in the cave is a reflection of what has occurred and existed on the surface for every day since yesterday back to the age of the rock units that are here, which is Ordovician age time.
Welcome back to the Ozark podcast. I'm your host, Kyle Veet, and I am joined, as always, by my good buddy and co-host of the show, Kyle Plunkett.
Yes, sir.
How are you, man?
Good. We're at the Ozark Underground Laboratory.
That's right.
We made an almost 3-hour drive over here.
This is one of our further ones.
It is. Through some beautiful Ozark country to then go underneath all of it.
That's right. Yeah, I'm really, really excited about this one. It's to kind of set it up. We talk a lot about, of course, what we do as outdoorsmen and guys who enjoy being outside on the surface, hunting, fishing, floating, hiking, all those things. And one of the things that you don't think about is what's happening underneath you,
mm-hmm.
and how it connects to what we do and how we impact the subsurface and how the subsurface impacts us above. And just the connection that we have and how it all ties together. And, we've heard a lot about karst. I feel like since we started the podcast 3 years ago, this word has come up, and I'm like, what is this? What does this mean? Is it a noun? Is it an adjective? Is it karst topography? Is it a play? Like, there's just kind of some ambiguity there. And the topography of the Ozarks is unique in that we do have this karst landscape and topography. And that's a porous surface and subsurface, and our guests will explain this in a lot cleaner detail here in a second.
More scientific terms.
Yes. Yeah. But it's just fascinating, and we like to highlight things that are unique to the Ozarks, and this is one of those things. And so to understand where we live and the place that we live on, I think a big part of it is understanding what's under your feet.
Mm-hmm.
And so to do that, I am happy to say that we have come to the expert on karst topography really in the whole world. I mean, I feel like I've been reading and doing some research on you. People come from all over the world to come visit this facility and your property here to dive into the caves, to talk with you, hear about what you've done. And so I'm happy to introduce to the podcast founder and owner of Ozark Underground Laboratory, and that is Tom Aley. Tom, welcome to the podcast.
Well, thank you. You exaggerate a bit, but it's very kind. Thank you.
And also with Tom, we've got Dave Woods. And Dave, you've who I've been kind of communicating with back and forth and have helped us set this up. And so I'm excited to get to sit down with both of you. And I know that you're kind of taking things over as transitions happen, and you're going to be kind of the future of the facility here. So I'm excited to hang out with you, and just want to say welcome to the podcast.
Yeah, thanks for coming. We are transitioning, and there's more folks involved than just me, but we're glad to have you here and show you what we do and talk about karst.
Yeah, absolutely. So let me just start with, I feel like I made a fool of myself. What is karst? Because, I hear this word and I'm like, man, this is so unique. Is it an adjective? Is it a noun? When you guys talk about karst, what are you talking about?
Let me handle that one.
Okay.
I'll give you kind of an academic definition. It's a three-dimensional landscape developed on and in a soluble bedrock in which there is appreciable groundwater movement through dissolved out openings in the rock. Key factors are three-dimensional landscape and a focus on the water. One of the big differences between karst topography and many other landscapes is the very rapid movement of a major portion of the water through the subsurface. As a ballpark number in the Ozarks, on the order of 3/4 of the water that ultimately reaches the major rivers and lakes of the region has moved into and through the groundwater system for at least some distance.
Okay.
Now, the transport of that water through the groundwater system, it's not seeping and oozing through the rock as it might in, say, a sandstone, but instead it is flowing along preferential flow routes, cave passages, and generally we call it a cave passage if the human body can fit in it.
Okay.
But a lot of the transport is clearly going to be through openings smaller than the body.
Sure.
So that's how a lot of the transport occurs. And that's why we can get travel distances through the karst groundwater system in the Ozarks that are commonly on the order of a mile a day.
Wow.
Surface streams don't go an awful lot faster than that.
Mm-hmm.
You know, at high flow they do, but at high flow, the groundwater system can go that far. For example, we've done one groundwater trace here at the lab that the travel distance was like 15,000 feet. First dye arrival was about 15 hours after we put the tracer dye in. So that's 1,000 feet an hour.
Okay.
That would be 24,000 feet in a day, and that's, better than 3 miles a day.
Mm.
Now, with that kind of transport and what has been a lot of the focus of our interpretive work here and our research work, with that rapid transport, you do not get effective natural cleansing of the water. You know,
Because it's not being filtered slowly through a sand or a more porous soil.
filtration takes out small things, but if you're transporting it so fast, you're just not getting effective filtration. You're not getting effective adsorption onto soil particles. Many of the natural processes that really clean up water in transport. So in karst topography, whatever goes down comes up. It's the inverse of the old adage.
Yeah.
But if you are to protect groundwater quality in the Ozarks and the quality of springs, you must protect the quality of water going into the ground.
Okay.
That's the place to do the protection. So there in 25 words or less is my definition of karst.
Gotcha. So for somebody has no scientific background, hasn't studied hydrology, hasn't studied anything about what you guys, your expertise is in, why is it important for the common person to know a little bit about karst and the landscape and what's going on under their feet here in the Ozarks? Why should somebody like Kyle here, who hunts and fishes and does all the things and floats, why should he care and why should this matter to him?
Well, on a human level, it's a health issue, for one thing. You talk to most people in the Ozarks and say, how often have you had a one-day flu? I'll ask you, how often have you had the one-day flu?
A one-day flu, like a sickness?
Like a stomach bug.
Oh, I don't know. Maybe twice a year.
I'd say twice every 2 years, once a year.
Healthy guy.
Okay.
Yeah.
There is no one-day flu. You have very likely either had food poisoning or contaminated water. So we attribute our problems to other things. They're often water-related issues. But beyond things like that affect people, good quality water is important to wildlife, the entire food chain. It's a major problem that has caused the damage to many habitats for cave-dwelling species, things like that. I've seen springs that have drained landfills, and the waters that run out of the springs are anaerobic, just like the water that comes out of a septic tank is anaerobic because of loading of oxygen-demanding materials. So I think if you appreciate the Ozarks, then you appreciate water and clean water. And just because it's clear doesn't mean it's clean.
Mm-hmm. That's a good reminder, because especially, I've got family down in Dallas, and you drive through Oklahoma and you go through like Lake Eufaula and you see, just muddy water in that clay. They've got a lot of clay in Texas and Oklahoma. And I talked to my father-in-law who hunts and fishes. I'm like, man, why is y'all's water so dirty? Ours is always clean. You could just go down and drink it. But just because it is clear doesn't mean that, you can just go down there and take a cup and start sipping on it.
You can sip on it, but you may pay a price for that.
You may get the one-day flu.
Yeah.
Yeah, and I think if we go back to what Tom started with, is about 3/4 of the surface water in the Ozarks has gone through the groundwater system at some point. If you enjoy recreating on lakes and streams in the Ozarks, 3/4 of that water has come through the ground.
Right.
So in order to ensure good, healthy aquatic communities and clean waterways, got to ensure clean groundwater.
Absolutely.
And then think about all the folks that get their water from the ground through, whether it be a private well or municipal wells. That's all groundwater that at some point in time came from the surface in the Ozarks.
Mm-hmm. Yeah.
How do you define it as groundwater? Because I know you're rain, obviously, but at some point, some of the rain's going to go into the ground. Is that all you're describing? Some rain may hit the river, but some's going to go up in the mountains, get into the system, and then that's going to be considered groundwater?
Groundwater, a broad definition, is anything below the surface of the ground.
Okay, that simple.
So you have infiltrating water. Generally, when you're talking of groundwater, you're talking of water in the saturated zone, below the soils.
Mhm.
There's a lot of water tied up in the soils. That's what supports vegetative growth and such. Generally, you exclude that from discussions of groundwater, but not always,
Okay.
because that's water transitioning from being on the surface to being in the ground.
Got it.
But this number, broad general number of 75% into and through the groundwater system, that may only be for a few hundred feet, but it may be for 30 or 40 miles to some of the major springs. For example, the longest groundwater trace done in the United States was done here in the Ozarks. It's something I did when I was working for the U.S. Forest Service. And it was a trace 39 and a half miles straight line distance to Big Spring on the Current River.
Wow.
And
39 and a half miles.
39 and a half miles. I should have found a place a little further upstream and made it 40, but
Yeah, man. So I remember reading you guys do about 40% of all dye tracing and groundwater tracing in the U.S. Is that accurate?
if the tracing is done with fluorescent tracer dyes,
Okay.
then that's our estimate.
So people really from around the country come to you for your expertise on how do we do this?
And we do the analytical work. We have an analytical lab here. And in fact, we run samples for groundwater tracing projects all over the world.
And is tracing one of the main components of what you guys do, or just maybe kind of talk me overview of what all you guys do at Ozark Underground Labs?
The tracing is sort of a niche specialty that we have. We work more broadly than that. For example, let me just go through the expertise of some of the key people we have here. Start with me. I have 2 degrees in forestry. I'm licensed in Missouri, Arkansas, and 2 other states as a professional geologist. So that's kind of broad. Dave's background, he has a couple degrees in fisheries biology. Trevor is about to complete a doctorate in geology, but a focus on contaminant migration. So clearly, with that kind of background, we're more than just dye tracing
Sure.
people. But it is one of the important tools that we use, has a fair number of subtleties in its application. And that's why, having done thousands of traces, we're heavily involved in tracing programs.
Gotcha. Yeah, I think it's pretty. It's probably a pretty easy pill for people to understand and swallow. Of our understanding our groundwater and where it comes from and where it goes is important. Everyone depends on water, like you mentioned, people, wildlife, plants, and that shows up. Thinking about if we all depend on water and the fish and the deer, and we all do that, and we have bad water, that sets us up for really failure in the future, and you can start to see species disappearing and things like that. I remember doing a project when we were probably in like 8th grade, and we went out to New Life Ranch, and we seined the river.
Mm-hmm.
We pulled the net across, and we
Flint
looked.
Creek.
Yeah, we looked at all the species in there, and they talked about, if you find this kind of crawdad and this many species, that shows a pretty good diversity, and that probably is a pretty good indicator of health of that stream. So the more degraded that stream gets and impaired that water is, it makes sense. The less species and less diversity you're going to have, which then creates a snowball of issues down the road. So I feel like people can kind of swallow that pill pretty easy in their mind of why water is important in understanding filtration and health of it and how it moves through our system. I'm curious, Tom, being a background in forestry and geology, I'd love to just kind of hear your story of how this all happened. And you're back, like, where did you grow up? Because I know you're not from the Ozarks. So how did you end up in Missouri, building this cave empire, if you will, up here in the heart of the Ozarks?
Originally from Ohio, in a coal and steel mining area, where I thought all cities were uniformly black in color, because that's the color that Steubenville was, because of all the coal burned in homes and in the steel mills. Lived in Washington State a while, graduated from high school in Norfolk, Virginia, went off to school at University of California, Berkeley. Went to school there about 7 years, did a little time at University of Arizona in Tucson. But basically, I was working for a large consulting company as their chief hydrologist in the LA area. And it's good professional work, but it was not the kind of thing I wanted to do. So 5 consecutive wrong turns on the freeway will bring you to Pro Tem, Missouri.
From LA.
From LA.
You don't say.
I wanted to develop what we have here, a research and educational facility focused on caves, karst, and land management in karst areas. And I thought in order to do this, I needed to find a good cave to create, in effect, a demonstration project. Spent 9 months full-time looking for a suitable cave to buy.
You stopped working and just were looking for caves.
That's right. I quit my good-paying job.
That's gutsy.
I quit on April Fool's Day.
Your boss is like, yeah, this is not real.
I'm going to go buy a cave.
Yeah. What is this?
Thanks for the paycheck. I'm
What
going
are
to
you
go buy
talking
a
about,
cave.
Tom?
In retrospect, that was gutsy, but I was young and naive. I've since corrected one of those problems.
So how did you pick Pro Tem, Missouri? I mean, there's got to be caves all over the country. And if you're spending 9 months full time, I'm sure you came across a lot of caves, a lot of properties that had some type of cavern or some system. What specifically about Missouri, Pro Tem, Missouri, and the Ozarks intrigued you enough to be like, yep, that's the place.
Well, I wanted a cave that had a wide range of conditions and features in a reasonably compact area. Some caves, they look rather uniform for the entire length of the cave. I had a long list of things that I kind of wanted to find in the ideal cave. I also thought it would be useful to have one closer to town somewhere. Here we're centrally located. We're not near anything, but that has a lot of benefits because we've not had significant environmental degradation of the features in the cave.
Mm-hmm.
The cave had the natural hydrologic features, and a lot of my focus has been on water that I wanted, had the geologic features, has a fantastic biota. In fact, we've been designated as a National Natural Landmark because we have the most diverse cave fauna of any cave west of the Mississippi.
Of any cave.
Right. East of the Mississippi, we're beat out by Mammoth Cave and Mammoth Cave National Park, but they have over a couple hundred miles of passage. Here we have about 2. So we
Wow.
have the kind of features that I felt were significant, both in the cave and on the surface, that made this a suitable site, and I could afford to buy it.
Yeah. That's kind of the thing is once you find this place, then it's like, can I buy it? Is it, I don't know, is it for sale? Were you looking at properties that maybe weren't even for sale? You're just asking broadly, do you have a cave on your property?
Not asking broadly, but, through references
Sure.
or talking with people. I did focus primarily on properties that were for sale.
Okay.
That's the best time to buy a piece of land when it's for sale. But I looked at other properties with caves, and I did not have very much money. I'd spent 7 years in going to universities, so that was back in the days that you didn't build up student debt.
Mm-hmm.
I came out of college not owing any money,
Right.
but hadn't worked all of that long, hadn't built up all that much money. So I couldn't pay very much for it, and didn't have much in the way of an established credit, but I was able to scrimp together enough that I could make the down payment on this, and
so you
got a job and everything.
and you started with a small piece, and then you've kind of expanded that over time. How much acreage did you start with, and then now what have you grown to?
First purchase, which was the majority of the cave too. The majority of the cave was under that land. It was 125 acres.
Okay.
Total ownership now of that my wife and I own and that the foundation owns is in excess of 3,500 acres.
Okay. So you've grown extensively, and is that just to make sure that you're capturing the entirety of the cave system within the boundaries, or are there reasons outside, that you're wanting to purchase land that doesn't fall if you were to draw a line straight down into the earth that is outside of the cave boundary?
Based on groundwater tracing we've done, the area that contributes water to the cave, called the recharge area for the cave, is about 9 square miles.
Okay.
That's more than 3,500 acres. But I have focused on buying land that was for sale in the recharge area for the cave, and focus special attention on lands that were potentially or actually creating adverse impacts on the cave.
Gotcha.
Trying to buy those. There are not many people who go out and intentionally by a big dump.
By
I
bad
did.
land. Yeah. And what kind of stuff were you seeing that was adversely affecting the recharge area and the groundwater?
Well, one of the concerns for the cave snail that we have. Let me introduce the cave snail first,
Please.
if I may. It's an aquatic snail. It's a federally listed endangered species. It is probably the smallest endangered species listed. It is the size of the letter O in my number 11 font. That's very small.
So is that like a grain of rice, essentially? Or
Well,
even smaller?
Rice is elongated, and this is a more
Circular.
spherical,
Spherical. Okay.
Half a grain
Snail.
of rice.
Okay.
Yeah, half a grain.
half a grain. Is this brown rice or white rice? I think we'll go with white rice because cave animals tend to be light colored.
Okay.
Anyway, I've sort of digressed into other things, but
And that's what's the name of this snail?
the Tumbling Creek cave snail,
Which is the name of your cave here.
yes. But one of the things that adversely impacts, like snails, is sediment. Well, if you have eroding pasture land because you're running too many head of cattle on the land and storms wash that water off and it sinks into the ground through losing streams, that can have devastating impacts on the cave. So that would be the kind of property that I was interested in buying.
And were you seeing those impacts from the time that you bought the cave? I mean, you start with, we've got these snails everywhere, and this is, I remember you saying before we started recording, this is the only place in the world that they've found this snail, right?
That's right.
And that's why it's got the name Tumbling Creek Cave Snail. So were you seeing that impact happening in real time of, man, when we first got here, these were everywhere, and 5-10 years in, we're not seeing them quite as much?
Yes, we've seen that kind of thing happen.
Really, in real time?
And as we became more knowledgeable, you see those things. You start watching things. In the the 1980s, we had about 15,000 of these snails because we did a census of them. Since they were unique to the cave system. By about the year 2000, our number was down to 150.
Wow.
That's a 99% decline.
Yeah.
Sediment was one of the problems, one of the identified problems. There were also problems from an invasive crayfish that has made it, was not initially in the cave, but has made it in because at high levels on Bull Shoals Reservoir, the reservoir inundates some of the springs that drain the cave. That created a pathway for the crayfish to get into the cave stream.
I see. When it would flood, water would get up and they would be able to get into the cave system.
They then have a route in.
I see.
So we have developed a program that over the last 10 years or so, we have trapped and removed over 7,000 of these crayfish.
Wow.
We've built crayfish barriers in the cave, trying to have crayfish-free zones in the cave, and have basically doubled the amount of crayfish-free zones in the cave we have. But that's only a fraction of the habitat that we had before.
Mm-hmm.
We have seen some recovery, not as much as we would like. I would estimate our current population is probably on the order of 500 to 1,000.
Okay.
That's a long way from 15,000. That's a heck of a lot better than 150.
Yeah, absolutely. And you've reversed that trend from a 99% degradation to you've actually increased it, which is the right way to go.
It appears to be we have done that.
Okay.
Doing the census work, you're picking up rocks in the cave stream and looking for these tiny snails on them. But if you're walking in the cave stream, there may be a snail under that rock and you crush him in searching for them. So you have to balance the need for the data against the risk you are creating in doing the counting.
Yeah, interesting.
So the data are imperfect. There's certainly nothing like we initially had with the number of cave snails that you could pick up essentially any good-sized rock in the cave stream and find a snail on it.
Man,
we can't do that now.
Yeah. And so, your efforts over the years of buying properties and restoring habitat, what kind of efforts have you done after you buy a piece of property within the recharge area to then, what have you done to convert that to a healthy piece of land that is now contributing positive effects to the cave system?
Well, I'll give you one example. We have planted trees for riparian corridors along losing streams.
Okay.
On one tract of land, we planted 50,000 tree seedlings. And the seedlings have a lot of root mass. We used 10 different native species, trees that would belong in the area: white oak, black oak, red oak, black walnut, dogwood, redbud, sycamore, a range of trees that belong in those areas. That substantially reduced sediment yield from those areas. Sediment that was getting into the losing stream, through the losing stream, and into the cave and into snail habitat.
Gotcha.
You have to dig a hole for each one of these trees. Our soils are pretty rocky.
Yep.
You wear out the blade on the planting tools.
Right. I know that very well. I've planted a few trees in my yard, nowhere near the number that you've planted, but it is a chore. They make digging on TV look really easy. It's like, that must be animated. That's not real.
They're not in the Ozarks.
Yeah, they're not.
Yeah.
They're not in our soil.
Yeah. Well, I've got so many more questions. I'm going to ask you one more, and then Dave, I feel like I'm leaving you out.
It's okay.
I want to
He's
bring
the
you in.
storyteller. Yeah.
We're gonna here in a little bit. We're actually gonna stop recording, and we're gonna go do a cave tour with Dave. Dave's gonna show us around, and we're gonna actually get in there and maybe kind of formulate some other questions and things like that. But
I'll have way more because we'll have seen it.
yeah,
Awesome.
But before we go and do that, Tom, I'm curious. I saw your map over here. I saw that you had something on here that showed like short or bear claw marks and things like that. And I know you shared some cool history with that. I want to hear that story, but also what were some of the craziest or cool things that you discovered once you started exploring this cave system as you acquired the land and as you started really spelunking and getting into it?
That's kind of interesting. I guess we have had a number of cool things. Identifying, for example, snails, saying, here's a snail, sending a specimen off to an expert, and the answer comes back, this is a new species, new to science, having discovered something that is new.
That's awesome. Yeah.
That's kind of neat. Just seeing things like when you're in a cave, I think Dave will probably show you some bear bones. We knew they were black bear bones from the paw of a black bear. Dave recently got them dated using radiocarbon dating and got an age date on them of about 17,000 years.
That's so cool.
That you can find things like that in little nooks and crannies
Had
in the cave.
Had they fossilized it all? And I know we'll see them here in a second, but were they were pretty well preserved for 17,000 years just to be
there was
laying
no
there.
fossilization. They had to extract collagen to do the radiocarbon dating.
Okay.
So they were still bone, and
Wow.
they're likely sitting in the same place that bear died.
Really?
Yeah, and the cave's name used to be Bear Cave
Okay.
before Tom purchased it.
Okay.
And there's like 61 or 62 other bear caves in Missouri. So that wasn't going to work for having a standout underground laboratory. But the hollow down here is still Bear Cave Hollow, and there's the Bear Cave entrance, and there's bear sign all over the cave. There's bear beds, there's claw marks in the sediments in a lot of the passageways.
Man.
And then these bones, and there's a number of other bones that Tom has found in the cave, as well as a jaguar bone, I believe, that was identified.
Really?
From the cave, yeah.
Now, when you say jaguar, are we talking?
And when you say identified,
What are we talking about here?
So the bone was identified as a jaguar bone by Dr. Oz Hawksley, who was at Central Missouri State at the time, and this was in the late 60s. Likely, a Pleistocene relic. So we've not had that dated. We don't know how old it is.
Mm-hmm.
But those are the types of interesting things. Peccary bones. So species from another time.
What is a peccary? Okay, two questions. Pleistocene. I don't actually know what time period that is. How far back would that have been range-wise? And then two, I don't know what peccary is.
So Pleistocene would be like 10,000 years back to a couple million years ago.
Okay.
So these are the mammoth and the short-faced bear and the steppe
Big
lions
cats.
and the big charismatic megafauna that were in North America during the Ice Ages.
And a jaguar could have been back at that time like what we think of as like a saber-toothed tiger, or would it have been maybe more similar to
It was
a
a
mountain
different.
lion?
It was a different species than the current Panthera species.
Okay,
So it's
gotcha.
Panthera onca augusta was the name of the species that was identified from our cave. That's no longer. It's an extinct species now.
Wow. That's crazy.
and a peccary is a little pig, right?
Right. Yep.
Okay.
Yeah.
Look at you knowing stuff. Good for you.
Are they still around, or are they also extinct?
They're not around in, as far as I'm aware, they're not around in North America, but there's
Okay.
still species of peccary in Central and South America.
Okay.
Maybe the southern U.S. as well. I'm not an expert on peccaries.
Okay.
Yeah.
Okay, gotcha.
So you're finding things
Man.
in this cave anywhere from 10,000 to 1,000,000 something years old.
Well, we have confirmed dated the bare bones at about 16,700 to 17,000 years old.
okay.
Okay.
We don't have good dates on the other things we've seen, but knowing what was around then, we can kind of narrow it down to a time period that it found its way into the cave.
Yeah.
But it's crazy to me that in
Wow.
one cave you're finding Ice Age, Pleistocene era animals that are no longer on the landscape. And in the middle of the 1900s, you found a species of snail that the rest of the world didn't know existed.
Right.
And then now you've reversed the trend of its extinction.
Yeah.
Its
Well, we
decline.
hopefully
Or
have
s-
slowed or stopped the decline.
Yeah.
It's still a battle to recover the species, and we're a
Okay.
long way from that. But
at least
we
turned
have
the trend.
another endemic species, and these species that are only found in one area are called endemic species. And it's a cave millipede,
okay.
Chetaspis aeliorum, Aley's cave millipede.
Cataspis
And
aeliorum.
you all likely get to see one when we go in the cave. So
Very
this is
cool.
another species that's so far only been identified from Tumbling Creek Cave.
Wow. So what's its is it Tumbling Creek millipede, centipede? What's the layman's term?
Aley's cave millipede, named after
Oh,
Tom
okay.
and Kathy.
Very cool.
And its habitat is bat guano.
Really?
Yes.
Right.
So
the bug named after you.
I'm not totally happy that it's named after me.
Yeah. You're like, what does this say about me?
The bug named
That's
after
so
you lives
cool.
in bat poop.
Uh-huh.
That's
Yeah.
awesome.
A lot of the things in the cave rely on the bat guano.
Yeah.
And we can talk about that when we go in. You'll see
Mhm.
there's lots of guano in the cave.
Yeah.
And that's the main source of energy for our community organisms in the cave.
Man.
Gotcha. Very cool.
And then you were showing us on the map, Tom, what might be a short-faced bear.
We don't know.
I want to hear the theory, though.
Well, there are claw marks in the cave. Short-faced bear were very large animals, so the distance between the individual claws,
Mhm.
when you see claw marks on the wall, are a pretty good indicator of what bear it was. There are a lot of claw marks in a section of the cave that bear could not possibly get to these days.
Mm.
Formations have grown and reduced the size of the passages into just tiny squeezeways that you can barely get in. So I've not been back there to measure the distance between the claw marks. At the time I first saw them, didn't know that might be of
Wow.
interest.
Yeah.
So, but there are caves in the Ozarks that do have claw marks of short-faced bear.
Man, that is so
And
cool. Well, we're going to get back there today. Kyle and I are going to crawl back there on hands and...
This requires vertical climbing gear to get.
Oh, yeah, I'm not ready for that.
I'm out on that.
I'm not ready for that. Dang it.
But as you deal with caves, what we have there is not just a sort of museum of some small piece of time, but what you find in the cave is a reflection of what has occurred and existed on the surface for every day since yesterday back to the age of the rock units that are here, which is Ordovician age time.
Is that because of sediment?
There are all sorts of things that you are looking at. They have different ages.
Mm-hmm.
So don't think of the cave and what you're seeing there as just a particular period in time.
Right, it's not
It
stagnant.
isn't.
It hasn't just stopped.
I
Right.
see.
Right.
I see.
Okay, I've never thought about that.
Yeah.
But that makes sense. If stuff's coming into the cave, then you really could day by day track what's happening on the surface.
Yeah, and it's different scales too. So there's things that are happening at a geologic time scale, which is something we can't really perceive
Mm-hmm.
or comprehend. And then there's things in systems that might have greater impacts from land use on the surface that
Mhm.
are changing overnight, and a loss of diversity of cave species, decreases in water quality and quantity.
Mhm.
So yeah, they're neat time capsules, but
Yeah.
they're also there's things occurring that if you're not collecting the data and paying attention, we're not noticing.
Yeah. Yeah, you can figure out what's happening from the farmer upstream that is letting his field get overrun by too many heads of cattle and then the sediment seeping in. But it's going to be really hard to track how that passageway that the cave bear or the short-faced bear may have gotten through is now no longer big enough for you to get into.
Yeah,
Like that's what you're saying.
those cave formations take a long time
Yeah.
to deposit.
Yeah.
So the
Okay.
fact, getting back to the bear sign, the fact that there's claw marks back there is indicative that that was from a long time ago, and there was likely another entrance to that passageway to allow those animals into the cave. So yeah, those are all the neat and cool things, but also there's a lot of concerns and stressors and threats to caves and groundwater that we try to keep track of and pay attention to.
Right.
You can get lost in the Pleistocene stuff because
Yeah.
it's fascinating, but there's a lot going on today in the cave, not just our cave, all over, that we need to be paying attention to.
Perfect. Well, I think that's a great time to go see the cave at this point. Tom, for anyone who wants to learn more about caves or maybe would like to come see this cave and before we lose you, what would you say to someone who wants to come learn and wants to learn more about just caves in the Ozarks or hydrology or anything like that?
Give us a call or send us an email. We'll see what we can work out.
All right. Sounds
Awesome.
good. We appreciate you, Tom. Thanks for joining us on here.
Mm-hmm.
Glad to.